Hello everyone. In this video we are going to build this an n8n workflow for network anomaly detection, which can detect anomaly from your telemetry data collected from a network and escalate them over a messaging channel. What you see on the screen is my Discord channel, and you are receiving anomalies like router 9 packet loss anomaly, critical 10.32. It means a specific device in your network is losing packets. There is a significant packet loss, along with the analysis of the anomaly as well. For example, what does this anomaly mean and why it might happen? This anomaly indicates a critical packet loss on router 9, which may have occurred due to sudden increase in network congestion. And it's possible that sudden spike in the traffic or a faulty network interface may have caused the packet loss. And there are more pointers to this anomaly, like root cause, concrete steps to resolve or mitigate, and additional data to collect if needed for the debugging this anomaly. Before we proceed, let us understand the use case. The use case in this video we are going to use to learn n8n workflow is network anomaly detection, which is very widely deployed use case for the monitoring of your network in your data centers, for example, in enterprise network, in your campus network. So it is ensuring that your network is always available, your services, your apps are always available, and as well as your data is secure. So having such a network anomaly detection systems in your network helps you detecting packet loss, latencies, DDoS attacks, for example, malware detection, or maybe internal misuse. And it at the end makes your network highly available. But in this video, our focus will also be towards learning n8n workflow. I have used this network detection as a use case only. Before we move forward, let's know what is n8n. n8n basically the short form of node automation or node based automation, as sometimes we call Kubernetes to be K8s. So this is very similar, n8n K8s. n8n is not a host for your application. Instead, n8n provides lots of interfaces of different types. Using those, you can connect to your apps and have the output of one app to pass on to the next node in your workflow. For example, the interfaces, the protocols using which you can connect to your applications in n8n are like REST, SOAP, gRPC, tons of DB connectors, CLIs, SMTP to speak to your email server, for example, and many more. Not only that, you can also do a bit of a coding using the code node. Here you can do basic data parsing, error handling if you want to do using JavaScript. That, by the way, we are going to do in our workflow as well. You will see in a moment. So overall, n8n is a very nice tool where you have various applications, piece of softwares, and you want to combine them to achieve a overall purpose. So let us dive into it. So now let us have a look into the design of our application and workflow. In this diagram, what you see on the top is our actual workflow. And everything outside of this top box are our applications. As I said, n8n is not a host for your applications, but it provides the interfaces. The only interface from our application to our workflow is this Redis. This one is the actual database. What you see in the box for n8n automation is only an interface node. Here you will only provide the credentials of the Redis and it will be speaking to our Redis. Now let us have a look into the each component in the diagram. So what you see here is our generator node. This is basically a Python script which I have created to simulate the network telemetry data, because I do not have that many devices to create a network and then generate the real life data. This generator in the code base you can find with the name network data generator. This is a script which will be hosted in a Docker container. It will be pushing all its data to InfluxDB here. So it has got all those credentials of the Influx database. Influx database, by the way, is a time series database where you make a data entry with the timestamp for a specific metric. For example, what was the CPU usage at a specific time, and then after 5 seconds you will make one more entry, so you can draw a graph out of that data. We will have a look into the InfluxDB web console in a moment. So this generator is generating the data. It has got these credentials, and then you will see several factors, several parameters which you can adjust to shape your telemetry data. How you want to generate your data into InfluxDB. For example, have a look at this first property, default anomaly probability. How often you want the anomaly in your time series data, means how often you want your CPU usage went high or packet loss was high. So this is deciding the probability. Raising this number will cause more probability and lowering this number will cause less. Again, this default noise level is the how high your peaks and drops when we speak about anomaly should be. For example, packet loss, how big should be the packet loss. So this factor is defining that thing. So once you start this container, it will start pushing the data automatically into the InfluxDB, simulating the real-time telemetry data coming from your network devices. The next component in our design is this detector. So detector's job is to continuously keep an eye on Influx database, and it has got some rules on the basis of what it decides whether this is an anomalous data or not. What are those rules? These rules are written inside this anomaly detector.py module. So there are again some baselines, some standard deviation, z-score, and it also takes into the context the time of the day. Traffic spike in the early morning, for example at 2 o'clock or 3 o'clock, it will consider it to be an anomaly or unusual activity in your network. But if the same anomaly is detected during the day with same amount of the traffic, it won't consider it to be. So I've tried to create those scripts in a way that they are as near to as real life network data and anomalies. Next is this Redis DB. We need not to do it. We have already a Docker image hosted in the public, not really hosted, but available in the public, which you can certainly host locally. InfluxDB is the same case, and this n8n workflow. So how to start all that is using this Docker compose file. Here are all the services, all the components, detector, generator, n8n, Redis, and InfluxDB. For sure, for detector and generator, they are not publicly available. We have built those scripts. So to start them, you will have to first build this. If you have this Docker compose YAML file and you have Docker and Docker compose installed in your machine, you can do it very easily. First do Docker compose build. If you are doing it first time, it may take longer than what it has taken now. Once built, just do Docker compose up and run it in background using -d option. Sorry, spelling mistake. All those services were already running, so it was quite fast. So once you have started all the containers, you can reach them on the web, like here. So localhost 5678 is the default port of your n8n service. So if you are launching it first time, it will ask you for registration. So you can provide your email and the credentials I don't know why they are asking it, and I couldn't find a way to skip that step. If you know, please let me know in the comments. Otherwise, just provide your email, or any email actually worked for me, abc@xyz.com, things like that you can do. And here is the workflow. Where it come from, I created it, but that will be available in form of JSON. I will make everything open source and will be available in the GitHub repository. You will find the link in the description. So once you have it here, by the way, import option should be somewhere here. Create workflow. Once you have the JSON, you can do a create workflow from here, but I have it already. Let's jump into the workflow. So everything is running. n8n is here. n8n workflow is here. So to correlate this is the workflow, what I was showing, and the interface is via Redis only. So this is the only connection between our workflow and our actual application. In here, this is my n8n thing, and this is the InfluxDB instance where our generator is pushing data and detector is detecting for the anomalies. Admin, and I think pass@123 is the correct password, which I have used here. You can find it in the service description here. Okay, this is coming from environment, then it would be defined here. Sorry, this is admin123. So the things are defined here. You can browse the code and find out the things, or adjust as you want. Sign in. So once you go on the home page of the InfluxDB, although you need not to get into the InfluxDB, the focus is on n8n, and our n8n workflow doesn't really interact directly with the InfluxDB, but okay, I just wanted to give you a feel about how it looks, the telemetry data specifically. So this is the network data bucket, and here are various kind of anomalies which we are generating using generator. For example, connection at active, CPU utilization, input and output octates, basically the traffic which is coming in and out of an interface, and the latency, the delay in the service, delay in processing those packets, the packet loss, how many came in and how many goes out, and what was lost in between this process. So if you want to really see a graph, you can always see it here. Just select this measurement. Measurement means one metric. Roughly you can map it like this. And mean, median, okay, select last and submit the query. It will draw a graph. If you really want to look into the InfluxDB, how it is showing. By the way, there are various techniques where you can see this data. In the most popular one is the Grafana stuff. There you can create more creative graphs and do some kind of data analysis in the Grafana, but InfluxDB itself also have quite a nice basic, I would say, interface for viewing graph. And for example, if you see a table view, so this is like that, but not really important from the point of view of this video. So this is n8n, this is our InfluxDB. Another thing is this Discord message channel where you will be receiving the messages. Now let us get into the workflow. So this is our Redis interface, and this is schedule trigger. So how it is working is, our detector is continuously pushing the anomalies detected into the queue, Redis queue. And this is a pop node here. This is popping the elements from the queue time to time. So what is that time is decided by actually this schedule trigger. So if you click on this, every 5 seconds it will trigger this Redis node, which is configured with the, if you have a look at this, the credentials of my locally running Redis instance. So this trigger will tell this Redis pop node to pop out one element, one entry from the Redis queue, which is about the anomalous data. Basically, whenever you want to add a new node here, you can just find out, for example, trigger or let us write it like schedule trigger. So this is the node. I haven't changed the name of those nodes, so with the same name you can find them in this list by clicking on this plus sign. Rest of the things, I will show you the configurations here. So this is Redis pop node. So by the way, if you want to run any node without running the full workflow, you can double click on it and do the execute step. What it is saying is, on the left hand side is the output of your previous step, and on the right hand side you see the output of your current step or node. So this is the timestamp information. The previous step was schedule trigger. So every 5 seconds it will ask this Redis node to execute, and what is the output of this Redis pop node execution is the data that it has picked from the Redis queue. Remember here, the Redis queue is here. So it is popping out one entry, and that's what the data it has popped out in form of JSON. So you can, if you want to see it in a pretty format, that's also available here. You can switch the visualization from here. And also all the time you see the input and output of each node here as well. So next is the code node. Code node is having a small JavaScript. Why I have this code node here is just because it has got a small check for the nullability. Sometimes I observe with the data that my detector, maybe there are some bugs, it was returning an empty JSON which was having a single node, this property name, and nothing inside it. So it's just doing a nullability check. Now execute this step. Okay, it is asking to execute previous step. So the previous step and the output of this code node is the same because nothing was null here, so it has passed the same data to the next step. Next step is basic LLM chain. So this is a very important thing. If we double click on it, you will see there are some prompts and things like that. So if you click on this small expand button, it will give you a expanded view. Here you can do editing more easily than in that window. So this is a previous code nodes output. Here I have defined a prompt that will be used by LLM to analyze and create a report basically out of this anomaly. This is one record that has come out of code. So let's go back. We are here. So all the checks it has taken, the Redis pop node has taken one record that is anomalous. The check have happened. This is not null. Now the record is with basic LLM chain node. What it is going to do is it is going to send this data for the analysis to LLM. So this is just a prompt which I have designed. So if you have a look into the prompt, you are a senior network operation analyst, an anomaly has been detected in the network which has following data. So what you see here is the some syntax using which you can parse the JSON data that is coming from the code node. So you can have a look. $JSON property name is device, for example, this thing. So router 9 will be the value will be replaced in front of device, for example, and so on and so forth. And at the end, I'm writing in the prompt like start the response with title of anomaly and important metrics in the title from data, which gives user a crisp and quick understanding about anomaly. If I go back to Discord node, this line, have a look at this. A crisp understanding about the anomaly. Router 8 packet loss critical 9.15, and then it starts the rest of the details about anomaly, which are written in the prompt afterwards. Then mention the complete anomaly data in the form of key value, this thing. And afterward, keep your this thing here. Then please answer each of the following in 2-3 short bullet points based on the metric data. Keep your entire response under 20 lines. And what are the bullet points? What does this anomaly mean? Likely root cause, concrete steps to resolve or mitigate, additional data to collect if needed for the debugging of the anomaly. That's how the response you are seeing in the Discord channel. What does this anomaly mean? Likely root cause, concrete step to mitigate, additional data to be collected if needed. For example, router logs, network traffic capture data, performance metrics. Now send it to your senior network engineer so that he can check the configuration or do further debugging. So this is what basic LLM chain is doing. It basically is having just a prompt to create a report, and this prompt will be sent to the LLM, the AI. I'm using my Groq. Groq is a platform where they are hosting several LLMs, and using a key provided by Groq, you can basically speak to LLM. For free, they have sufficient amount of token, for example, to build such a demo. If you double click on it, how do you configure it? Just a Groq account. Groq account have this API key, that's it. And the model. I'm using quite a basic model, you can say Llama 3 with 8 billion, but it was good enough to provide me such a nice report, as you can see in the Discord. So this is my Groq chat model node. By the way, by the same name, you can find it here. Whenever you say like basic LLM chain node, if you want to create one, you will have to provide an actual LLM provider node as well. It could be your OpenAI or anything else. At the end, we have a Discord channel node, Discord server node, or whatever you want to call. So how do we configure it? I have used Discord especially for this demo. It was very easy to configure a webhook here. You just need a webhook for this channel and provide it here, and that's it. Execute this step, execute previous node. You will see, okay, this is the output of your previous step, that is LLM. LLM report about the anomaly. The anomalous data was coming from the previous steps, Redis, and then that code node checking for the null, and the LLM provided this report. Now, this code node's job is to forward this anomaly to the channel, and it says success. And I see this small balloon. It means I have a new message in my Discord channel. What it is about is router 10 packet loss anomaly critical 7.82. Why? Baseline reason loss is greater than 2%. The packet loss on router 10 exceeded the critical threshold of 2% at this time. Yeah. So our workflow is working. So every time, as you can see, one item is being passed because it's a queue based thing. So every time Redis node is popping out one item at a time, and it is being passed and being sent to the next steps in our workflow. So now let us run our workflow. So using this execute workflow, if I click on this, all the workflow will run only once. And that is why I have used schedule trigger node. So once it has run, it will pop out one item out of Redis queue. By the way, in the background, Detector is continuously filling our queue with anomalous data. But whenever you execute this workflow, it will pick up one item at a time. You might be hearing this sound coming from Discord as an indication that there is a new message on my network anomaly channel. This time again a packet loss has been detected. There are, by the way, several types of anomalies which I have created using my generator node, as you can see later on in the code. But the data, the queue is so huge with packet loss only, but the consumer, the Redis pop node, is running only when I am clicking on this button. So what do I need is, I want to continuously run this workflow. You can do that by activating the workflow. Just move that button here, workflow activated. Okay, thank you. And now it is activating. So now it is continuously working every 5 seconds. And now my Discord is informing me with a sound every 5 seconds. It will be more than 5 seconds because there are more processing. 5 seconds is the time of this trigger. So there are certainly latencies caused by this Redis, then this code wouldn't cause that much, but this LLM processing will also cause some delay, and then there is a delay between this response sent by basic LLM chain to this Discord message. But yeah, basically this is invoking the Redis pop node. This schedule trigger node is invoking Redis pop node every 5 seconds. So almost nearly 5 seconds I'm hearing a sound from my Discord channel here. Packet loss, packet loss, packet loss. What is this about? Again packet loss. So we have mostly the packet loss anomalies. Okay, let it run. So the pop sounds I will continuously listen. I'm going to deactivate it for now. So further, I have a few suggestions of improvement if you are going to use this in your actual network, or maybe kind of workflow in your network for anomaly detection. For example, if we have a look into the design, I have this detector which is having pretty much hard-coded rules. If you will have a look later into the code of this detector, it has several factors which are deciding or which are considering a specific record to be a anomalous data issue. Instead, you can consult LLM or AI here. You can pass that data with a different prompt which might or might not have the similar rules in my detector, and it will decide, the AI will decide whether this is an anomaly or not based on your prompt. In prompt itself you can decide the rules. Or if you are okay with such a detector, that's also good. But yeah, as I said, you will either have to say here, for example, the time context I have kept in the logic. In the morning, in the early morning, traffic spikes are unusual. So such things are better handled even if you miss in your prompt by AI than having hard-coded rules. And another was this schedule trigger. This is invoking every 5 seconds. Instead, if you can have a queue listener kind of node or a process which pops out an item as soon as it is in the queue. There is nothing harm in that as well, just that the alert you are seeing in the Discord is a bit stale, at least 5 seconds in the worst case. So queue listener will be more real time kind of implementation of this workflow. And also you can consider escalating the anomalies based on their severity to different channels. Having escalated those severity to messaging channels like Discord or Slack or Microsoft Teams is good, but if it is really anomaly like 16% of packet loss, 20% of packet loss, there is something wrong with the hardware maybe. So such high severity anomalies you may want to escalate via WhatsApp to your senior network engineer, for example, for immediate analysis of that hardware or whatever AI has suggested what to do in such cases. For example, here if you have a look, concrete step to resolve mitigate. So such part for high severity anomalies can be escalated over WhatsApp channel to the network team who is working 24/7. So such enhancements you can do in your workflow. Be creative. There are lots of things which you can do in n8n. So at the end, I would like to highlight a very important point actually. You always need n8n? Not really. If you are having a very simple workflow with a few nodes like this, although this workflow have a possibility to scale, but if you really have a workflow which is very simple, it's better to use some scripting to make a workflow out of a script. But can't we do everything with scripts? Why we need n8n at the end? Sometimes scripts cannot do everything. That's why n8n is so popular. There are several places where you can consider n8n. First would be visual workflow design. How nice is this workflow looking here? And whenever there is a failure, you will see the red indication as well. There are lots of built-in integrations. For example, think of coding a Discord driver which can connect to your Discord channel. Think of writing a interface to your LLM. Think of writing, okay, for Redis there are lots of things, but it can be anything which you want to connect in your workflow. Then you will have to write the drivers. So this is the pain which n8n takes away from you. Error handling and retries. You can catch exceptions in your workflow, send notifications, and you can make decisions in your workflow. If exception occurs, do this route, follow this route. If it doesn't, follow this route in your workflow. Such decisions you can do in your workflow very easily in n8n. And the changes are very easy. If you really want to scale your workflow, for example, in this case, I was mentioning you should add more escalation channels, for example, WhatsApp or Teams. It's very easy. Otherwise, you will have to re-script, dive into the code, and adjust your workflow in case you are not using n8n. So there are lots of use cases where you really use n8n, especially in case you have really complex workflows, for example. At the end, in this demo, we have seen only the tip of the iceberg, I would say. n8n is capable of doing a lots of things. It's a de facto tool those days when we speak about workflows. It simplifies the workflows, and still your applications can remain in isolation, can be developed in isolation. They need not to know, okay, there is something called n8n and I need to integrate there. So for the simpler workflows, still the scripts make sense. But if you really see that in the future your workflows are going to be complex, then it's a good choice to go with n8n. I hope you find the video informative. Thanks for watching.